building across a multitude of different chassis. So probably the best way to think about us is, more so as a technology firm than rather a traditional automotive manufacturer. There's really three main parts to our business. First one's our CBU product, which is the vans, where we import a glider chassis and then electrify it. Second part is our truck side of the business, which is where we source a glider through someone like Isuzu or Hino, and then electrify it and it's delivered as a new EV vehicle. And the third part of our business is actually around licensing, so whereby we license our technology to OEM manufacturers, so they're able to build that technology down their factory rather than having to develop their own. This just goes through some of our truck models. So the smallest ones we do, still under development actually, is about a C-Drive 60. It's around that 3.5 to 4 ton GVM type vehicle. With the heaviest one being the C-Drive 180, range up around that 200 to 250 max type range. Most of our trucks, they're up around high 200s to 300, that sort of thing. And then the van is up around that 300k mark. This is our global footprint. We've opened a number of offices recently. We've got now ones in Vienna, Bangkok and Los Angeles, as well as here in Auckland. It's our facility in Dandenong, where we actually build everything at the moment. So in the top right you can see our assembly area. That's where we do all of our trucks and our vans at the moment, as well as a lot of our like initial fit-ups for working with OEMs. We're actually about to open, in about 2021 we'll open a new plant, which a lot of people have been talking to me about, out on the shop floor, out on the display floor. We're opening a new plant in Morwell, so that will manufacture the vans specifically, and any volume orders that we get for trucks. So if someone orders, say, 10 trucks that are all going to be the same, we'll just build them down that through that assembly facility. Dandenong will remain open, but mostly doing trucks and then research and development and design. And this is a bit of a short video on vehicles that we've got in the field at the moment. Sorry guys, that's running really slow. We might skip that or we'll be here for 10 minutes watching the video. This slide really goes through battery pricing for us. Where commercial vehicles make sense from an EV standpoint was really when they crossed over from being just sound from an ecological standpoint to one where they started also making a lot of sense from a total cost of ownership or a operational standpoint. And a really key driver for that, obviously, anyone who's done a DIY vehicle will know that the batteries are really where the majority of your cost is going to be located for a new vehicle build, and we're no exception. So really where for us it started to really make sense from an ownership standpoint, a running cost standpoint for commercial vehicles, was really when it crossed over the threshold around about $300 per kilowatt hour and got below that, which I think was around about Q3 2016, roughly. And a lot of that's really around the development of not only battery technology in general, but also in personal electronics, things like that. It all feeds through. And because of that, our battery technology has improved dramatically, which allows commercial vehicles, it's not necessarily our battery technology, but commercial vehicles to become more viable as they have a greater range, or they're able to carry greater weights over that range. This goes through a bit of our system sub-design. So the system's designed to be modular. So a key part of the technology that we've developed is the idea that people are able to upgrade the vehicle throughout its life, rather than having it being time-stamped to a specific point in time when it comes out of the factory, like an integrated type design. So things like your onboard charger or your battery system itself is really the ideal areas where we'd see that working for an operator. This goes through the design of how it's actually put together. So because we don't run a transmission, we're able to build the vehicle in a pretty significantly different way to how traditionally trucks are built. Traditionally, trucks, you'll have your engine up the front, a cooling system up the front, followed by a transmission and a drive shaft to the rear differential. Because we don't run a transmission, we don't have to necessarily subscribe to that model. So our engine actually, our motor, is actually located right back here in the truck product, so only just in front of the diff controller, and then your batteries are actually up underneath the cabin and between the chassis rail. So we do this for we do this for a number of reasons. Dynamics is a big one, so because of its weight being on the centre point of the vehicle, it's going to ride and handle a lot better. If you've been in one of our electric trucks, I think we had one last year, they ride significantly better than their diesel counterparts with no vibration through the driveline coming through, or heat or noise or anything like that. The other side of it is around chassis real estate. So we already consume a fair part of real estate on the chassis with our high voltage box on the right and our cooling system on the left. And then finally, from a safety standpoint, by putting the batteries between the chassis rails, we afford them an inherent degree of impact protection from a side impact event. So obviously the first one that jumps to mind is something like a car T-boning a truck, but it can also be things a lot more simple than that. So thinking along the lines of trucks, something like a 12 pallet taut liner with like the pullback wall, loading in a dock or in a factory, and then someone on a forklift lowering the forks too much and driving into the side of the vehicle. By putting it between the chassis rails, we are avoiding those sorts of incidents, which we think is potentially problematic for electric trucks going forward. We believe there will be eventually regulation around placement of batteries to avoid those sorts of incidents. Just goes through the installation. And some of the vehicles we've already done. So we've done a number of Isuzus. There's a couple of those running around Melbourne. Hino, we've just delivered 3 of those for IKEA up in Sydney. Because IKEA's looking at changing over pretty much all of their fleet globally, I think by 2025. Iveco, that was one of our first electric garbage trucks for Australia. So that will be operating down in the city of Casey, along with 2 Mercedes Iconic type trucks. Ford were working on a number of a number of solutions for them with their vehicles in the US. Part of that licensing type approach. Just goes through the van a bit, so you can see our sub-assembly for the van in the top right. That is essentially bolted into traditionally where your engine and transmission would sit. It then runs directly through a drive shaft into the differential with batteries either side of that running underneath the floor, which you can sort of see a bit on the vehicle out on in the display area. The trucks, there's just a couple of our lighter trucks. We've got 4 of those for Woolworths with their home delivery fleet. They've got 1 heavy vehicle with them as well, doing depot-to-depot refrigerated freight. Up to our heavier vehicles like the ones for IKEA with home delivery, and then into our really heavy vehicles, so things like garbage trucks and that heavy Woolworths that I spoke about before. And there's just a quick shot of some of our techs doing installations on a couple of vehicles. And then another project we've been working on recently for Isuzu in the US. And that really sums up what we do, guys, and where it's going. So is there any questions or anything like that I want